Hi there folks. Today we're going to be looking at reflection and rotation matrices. So if I think about reflecting this line here, which goes to the point 2, 3, so is the position vector 2, 3 there, then I end up coming down here if I reflect in my x-axis. So I get to the point 2, minus 3. So its position vector is 2 over minus 3. So let's examine what's happened. The x has stayed as the x, but the y has become minus y. So we need to look at a matrix. I'll use the example 2, 3. If I multiply by 2, 3, I get to the answer of 2 minus 3. Well, if I'm thinking about my top row, I need to keep it the same by multiplying 2 by 1 and then 3 by 0. So 1, 2 is 2, 0, 3s are 3, 0, 3s are 0, so I end up with 2. Now on this next line, that can be easily done by doing 0, 2s and minus 1, 3s. So for a reflection in the x-axis, I have this matrix here. Because that will change, that will keep my x's the same and will make my y's negative. So on the next one, I'm going to reflect in the y-axis, which will give me this point here. So instead of being at 2, 3, we are now at minus 2, 3. So my x goes to negative x and my y will stay the same. So considering the point that we've been working with, 2, 3, I need my x to become minus and my y to stay the same. Well, it doesn't take much for you to look at this and think, okay, if I need my x to stay the same, and my x to be negative, doing that to get my top row will give me the negative lots of 2 and 0, 3, so that gives me my 2 in total there. And if I want this one to stay the same, 0 and 1 would give me 0, 2s and 1, 3. So this reflection here, this matrix here, would give us a y-axis reflection. Now, let's look at reflection in the line y equals x. Well, let's put the line y equals x on here for a start. If I'm going to reflect in there, I'm going to come to the point here. So my reflection is going to be there. So what started off as 2, 3 has now become 3, 2. So my x has gone to y and my y has gone to x. So again, thinking about how that could work in terms of a matrix. If I want my x to become the y value, I want none of the top one and then one of the bottom. And if I want my y to be my x value, so that gives me the 3 there, obviously, my x to be my y to be my x value, I want one of the x value and none of the y values, so that will give me that there. So this is what we have for a reflection in y equals x. Considering y equals minus x, let's put that line in there. This is going to be a bit trickier. So if I were to draw directly to the line and through the other side, I get to this point here, which is minus 3, minus 2. so my x becomes negative y and my y becomes negative x. As that would suggest, the y is equal to the negative x. So how does that work? Oops. So to get this number here, I need none of those and negative one of those. And to get this number here, I need negative one of those and none of those. So that is going to be a y equals negative x reflection. Okay, so 4 matrices, but we're just considering what would happen to that single point. Now, when it comes to rotations, I'm going to still use the same point. So I'm still using that point 2, 3, and thinking about it as a position vector. Now, if I rotate that over to this side, I end up at -3, 2. I go through 90 degrees anti-clockwise. So I get -3, 2. So considering what's happened, the x has become negative y and the y has become what the x was. So thinking about how we can do that, make the x the negative y, so if I go 0, -1 and the y becomes the x, 1, 0, I think that would work. And indeed it does. And then if we come down here again, rotate through another 90 degrees, I get to -3, -2, sorry, -2, -3. And so thinking the x has become negative x and the y has become negative y. So that's x just becomes the negative x, that would give you that. And the y has become negative y, which would give you that. And again through the next rotation, so we're now at 270 degrees anti-clockwise. We come to the point 3, -2. So my x has become y and my y is now what negative x was. So in terms of putting that into a matrix, x becomes y is that, y becomes negative x is that. Okay, so we've now got 7 different matrices which you can learn, or you can just think about a single point and what would happen to it. Now when I look at this one up here, I might think, well, there may be a connection to these angles that I'm using. And of course, if you're looking at a connection to angles, you might be thinking trigonometry. Well, in terms of 90 degrees, that's cos 90, that's cos 90, that's sine of 90, but that is negative sine of 90. And in terms of 180 degrees, you might see that that's cos 180, that's that's sine of 180, that's sine of 180, that is cos of 180, and that is cos of 180. And in terms of 270, that's cos 270, that's cos 270. This is sine 270. And this one is negative sine 270. Sine of 270 is negative 1. So to get that back to a positive, we have to do the negative negative. So we seem to have this pattern: cos, sine, cos, negative sine, cos, sine, cos, negative sine, cos, sine, cos. I didn't have a negative sign there, but actually because it's 0, positive or negative sign doesn't make any difference. So if you want to rotate via an angle of 30 degrees, you might think about the matrix cos 30, cos 30, sine 30, minus sine 30. So that would be root 3 over 2, root 3 over 2, a half, and minus a half. So if I wanted to rotate my point through 45 degrees, anti-clockwise, it's always anti, I would have to do root 3 over 2, root 3 over 2, minus a half, and a half, times by 2 over 3, which would give me, so root 3 over 2 times 2 is root 3, and then minus a half times 3 is minus 3 over 2, so that's root 3 minus 3 over 2. And here we have half times 2 is 1, and root 3 over 2 times 3 is 3 over 2 root 3. So that's 1 plus 3 over 2 root 3. If I get my calculator, this will give us some sort of idea about where that is. So I've got root 3 minus 3 divided by 2 is about 1.22, and 1 plus 3 times root 3 divided by 2 is 4.67. Just check those. Root 3 minus 3 divided by 2. Oops. Root 3 that's a bit different. I was sure that one wasn't right. So that's .232, and I'll check the bottom one. 1 plus 3 divided by 2 times root 3. 3.59. You've got to check you get these into the calculator properly. 3.60. So I'm actually looking at point 0.232, so that's up here somewhere, and 3.6, which is about there. So that would be my 45 degree my 30-degree rotation. Okay, so sorry for not quite getting that right, but after double checking, I'm happy with those values. Now, it'd be really fun if I could find a protractor and measure those. Oh, yes, exactly 30 degrees. Perfect. Right, so this matrix is really important to learn. So alpha degrees anticlockwise is going to be given by a matrix of cos alpha, sine alpha, negative sine alpha. But you can always consider what happens to a single point, and that would really help you. Okay.